Ever wondered what makes SVMs so unique in machine learning? Let's dive into the world of support vector machines, a powerful classification method in AI. Their ability to work with small datasets and resistance to overfitting sets them apart. So strap in as we take a quick but thorough exploration of SVMs. Now, you might be asking, what exactly is a support vector machine? Well, imagine you have a bunch of data points scattered on a plane. SVMs essentially find the best line, or in higher dimensions, a hyperplane, that separates these points into two distinct groups. The support vectors are the data points that the margin of this hyperplane nudges against, hence the name. These vectors help in defining the decision boundary. Sounds complex? Don't worry. When you see it in action, it's beautifully simple. So, what sets SVMs apart in the realm of machine learning? Their effectiveness in high-dimensional spaces, even when dimensions outnumber samples, sets them above the rest. Plus, their memory efficiency, using only a subset of training points, is commendable. In essence, SVMs offer a simple, elegant tool for classification in machine learning, making them a go-to for many professionals in the field.